I'm going to write down a bunch of stuff. Don't worry about it. This is just how we define alpha, what we colloquially call the fine structure constant. It's that dimensionless number that's close to about 1 over 137. So like the whole Rick and Morty, it's Rick Sanchez, the main protagonist, is from universe 137. Ah, pop culture, you see. All right, so the whole fine structure constant, alpha. Oh God, that's a funky looking alpha. God. I need penmanship. Penmanship and spelling were my worst subjects. All right, so we got our little fish alpha is defined as, we got this E squared, so that's the charge of a proton or electron. They're equivalent, but opposite charges. So you get positive and negative to our understanding, or at least convention. If you square a negative, you're gonna get a positive. So that's why this kind of makes sense. Okay, so we get elementary charge squared over 4 pi epsilon naught, which is the electric constant, times the speed of light, times the elementary unit of action, h bar. This is what it's defined as. Now, perhaps you can get an intuition for this. For me, I'm like, I don't know, so a square charge divided by a circle, the electric permittivity of free space at the speed of light via the minimum unit of action. I could try to think of something what that is, but then we use a little intuition. Now, most of this just came from Wolfram Alpha and it told me, but this is a dimensionless number. Now, all these things here, except this 4 pi, which you can think of kind of like a sphere, these all have dimensions. So that means that this is charge squared, and it's going to cancel out to something that's dimensionless. So that means that all this whole crazy thing here must end up being charge squared as well. And then when you go through the stuff, you end up realizing that you can rewrite this whole thing on, let's say, computationally reduce it to a much simpler definition or notation. So you can just change this whole thing to elementary charge over q sub p, which is the Planck charge, and you square that whole dang thing. Huh. So, at least for me, now, and again, this is nothing new. There are people that have known about this. I've watched, was it John Macken there? There was some physicist on with Fractal, and I should probably actually link that, where he presented this to her, and she's been really big on units. Shout out to Fractal Woman.
I thought it was really interesting that electric charge squared divided by Planck charge squared is equal to the fine structure constant.
Yeah. Oh, yeah.
Okay, so that obviously that is a direct connection between the what is Planck charge. When you take, so that gives sort of a tangible thing. Well, there the fine structure constant is right there. It has to do with charge. Has to do with the relationship between elementary charge and Planck charge.
And one of the things you realize is, well, wait a second, that whole dang thing is basically just a Planck charge. So it's like, wait, so you have elementary charge over Planck charge squared equals the fine structure constant. All right. So again, let's just share with the class. So let's hopefully Wolfram Alpha servers are not being heavily bogged down like they were the other day. So let's just do this. All right. So first, let's just type in alpha. So it's going to give us, we want the unit. Okay. So here's what we have here. So this is alpha, the fine structure constant. Its approximate value is this. Some argument once you get to the last digit, but that's, we'll pass over that for the sake right now. So that definition is the whole thing that we have on the board there. That e squared 4 pi c epsilon naught h bar yada yada yada. Okay. So let's try to simplify this. So let's just do elementary charge divided by the Planck charge. Square the thing. Oh, look. This appears to be the same number. Huh. 0.00729735256. 0.00729735256. Oh, It seems to be computationally equivalent. Imagine my shock. Yes, that's a charge pun.